Oh, ça fait ça. Pronto? Ciao Enrico. Sì, 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 ma sono già online, non mi vedi? Io provo ancora a condividere lo schermo un attimo, Enrico, così mi dici un attimino. Ok. Ah no, scusami. Ok. Ciao, ciao.
No, no, that's Loic?
Sì? Oh,
Okay. Can you go in presentation mode just to make sure we can see the? Because you see, we were seeing the presenter mode, not the presentation mode.
okay, just a moment.
I want to try to.
Okay, okay.
Okay, that's correct. Yes, yes, it works. Okay,
Okay,
thank you.
perfect.
Morning.
Morning.
Good
Okay, I
morning.
guess we wait a few minutes more, right?
Okay.
Yeah.
Okay,
You on full time?
I hope so.
Someone
I mean,
start everything.
yeah. Where should I sit? Here or
Wherever you want.
don't start the screen.
Just come out once more to set my I forgot to put. Okay.
Yeah, we can.
It was just to put face on voice, right?
Yes, we can see you on the other screen. Yes.
Okay.
I'm mute. I guess.
Ready? All right. So good morning again, everyone, to the fourth and in this case last day of VCOIC. I think we had a really nice social dinner last night and good discussions. It's time to continue now JAG hybrid. So Enrico, do you want to take it over?
Yeah, thank you, Yanis. And so in this JAG hybrid session this morning, we will have two presentations, two remote presentations, one by Loic and one from Brian. So I think I don't have to say many things, and I just leave the floor to Loic for his presentation. So please.
Okay. So hello, everyone. Thank you, Enrico. So we will start with this first presentation on the result on the subjective study that we conducted to analyze a bit the implications of the agreement of several objective measures on a large-scale data set. And we took the opportunity as well to study the sensitivity of this matrix. Okay. And let me give you a bit of context. Now, I mean, in this era of deep learning, we are interested, okay, in building large-scale data set, but something that is still missing, particularly in our community, is the ability to really control the perceptual distance between stimuli in this large-scale data set. Okay. And why could this be so relevant? Because I mean, I personally think that it is relevant to control this perceptual distance because in modern applications, we are now mostly interested in moderate to high quality. This kind of narrow the quality scale, right? And if you have a large scale data set, there is a large risk, okay, of just having a lot of just asking people to annotate a lot of stimuli that are but without avoiding redundancy. Redundancy in the sense that you ask people to evaluate a lot of stimuli that basically have the same perceptual quality. So the question of controlling, being able to objectively control the perceptual distance between stimuli appear to be important. I mean, except for what I just said now, there are other applications, right? What might think, for instance, that if I am able to identify a subset of stimuli whose perceptual quality can be assumed to be the same, then you can characterize these stimuli to say, these are the hypothetical reference secrets that will yield the same quality, okay? At the same time, you could use a strategy that allow you to identify stimuli with similar quality as an effective determination approach when training a deep neural network. I mean, beyond all these aspects, we'll say another thing we want to say is that typically we study the accuracy of video quality metric, just focusing on correlation. Why it will be interesting also to analyze the sensitivity, putting it in comparison to the sensitivity of human subjects. So you need to take into consideration just noticeable difference. That is another point where probably, okay, considering controlling perceptual distance will really help. So what are the questions that we were interested in this particular research? The first question is, can I define simple statistics on the agreement of many metrics and use them to identify a subset of images that are perceptually similar? Okay. This is one question. And as we see in this presentation, we defined two simple statistics to characterize the agreement of metrics. And we kind of use them to we use them to effectively identify a subset of images whose quality belong in let's say stay all within one JND, okay, as perceptual distance. Another interesting question is, I mean, if I do have a strong agreement within the metric, is the common quality score predicted a more reliable, okay, a reliable estimation of the perceived quality? Okay. And the very last question again is about the sensitivity of the state-of-the-art DNN matrix on the large scale, let's say modern content in the sense of high resolution, okay, and so on. So these are the questions we wanted to evaluate in this study. Now, let me introduce you. Let me tell you exactly this. Talk a bit about the setup of the experiment that we run. So, basically, we collected 22,000 images, a bit more than 22,000 images from professional website. The images were of very high resolution, obviously, and we made sure that the images that we have that we collect, okay, have moderate to high quality. Later, what we did is that we computed the score of 11 objective metrics on this data set here, okay? And we computed this score not only at the native resolution of the images, but also, okay, after downscaling the image to full HD. Then, for each image, and so for each image I and each metric J, we found the rank Rij, okay, that's that the metric attributes to that image, okay. So Rij, so for each, at the end, for each image, okay, for each metric, sorry, you have a vector of ranking values going from 1, okay, to 22,300. This means at the same time that for each image, you have the 11 ranks, okay, 11 values, 11 integer values associated to the 11 ranks that corresponding to the rank that each metric associates to that image. Now, for each image, you can take the average of this rank. That is what we call mean rank, okay? And obviously, the lower is the mean rank, the better classified is the image. I mean, the better ranked is the image in the data set. So this mean rank is an indicator of the relative quality of the image in that data set. At the same time, we took the standard deviation of these 11 values. This is an indicator of the disagreement, right, between the ranking given to the image by the different metrics. The question is, using these two statistics, one wonder whether if you cluster images based on these two statistics, the cluster that you obtain could have the characteristic that we are searching for. That is, within this cluster, especially within those for which the standard, the STD rank is low, are we going to, can a subjective test confirm similar perceptual quality? Okay. And in fact, when we plot the STD rank versus the mean rank versus the STD rank, we have this kind of parabola. This should remind you something, right? The MOS versus source, okay, relationship. And what we did is that we selected 4 clusters, okay, of stimuli, 4 clusters of stimuli for our subjective experiment. And in particular, the blue cluster is the cluster of images where the STD, the mean rank is very low, so higher quality, and there is strong agreement between the metric. Then you have the red cluster that I'm going to call cluster 4, where the mean rank is high, so the lower quality in the data set. Obviously lower or higher in terms of objectively speaking, okay, the metric. And in the red cluster, we also have low, okay, high agreement of the metric or low disagreement. Then we have we pick two clusters in the middle of this parabola here. One corresponding to let's say moderate values of mean rank, but with low STD rank, so with strong agreement. While the green cluster here, okay, are images with moderate value of mean rank, but very high disagreement of the metric. Please note that the width of the cluster, the projection of the cluster on the x-axis is more or less the same, right? And in each cluster, we picked a total of 300 stimuli distributed between the cluster, as you can see on this slide here. Now, we run a subjective study, a pair comparison-based subjective study, where people evaluated, okay, a total of 1,000 of pairs, okay, and the pairs were constructed by, both between and taking images between and within clusters. And we selected these pairs to evaluate in a way to, to enable an estimation of the on the let's say latent ground truth quality of each image, okay, using the approaches, consolidated approaches as the Truston case 5 model. A total of 28 subjects participated into the experiment. During the experiment, each subject was shown a total of 300 image pairs, and the subject was asked to look at. The image was shown. One image was only one image was shown at the time. And then the subject was required to look at the image, then use the left and right arrow to go to the other image, iterate between the two images, okay, until he he was convinced and he could take the image that has greater quality according to him. So there was no time constraint, okay. Obviously, subjects rated different pairs of images, but with the unique condition that there were 50 pairs of images that were repeatedly rated by all the subjects in the same order, okay. These pairs were presented in the same order. This was done obviously to later, evaluate the consistency of each subject, as well as the reliability of the collected data. Now, once we got the pair comparison data, we needed to estimate the ground truth quality or the subjective score of each of the 300 stimuli used for the subjective test. And we use here the Truston case 5 model, okay, that basically, as you know, assume that the probability that image I is better than image J could be expressed, okay, as the standard deviation of a normal distribution, the distribution, the cumulative distribution of a normal distribution computed at the difference between, okay, the subjective quality of stimuli I and the subjective quality of stimuli J. This is a probabilistic model that you can use and a maximum likelihood estimation approach, okay, to estimate the ground truth quality QI of each stimuli, of each stimuli I, okay, of each stimulus I. That is exactly what we did. Now, having the let's say the subjective score of each stimuli, of each stimulus, what we did is also to estimate the just noticeable difference on our subjective scale, okay? Like, what is the minimum delta Q, okay, for which people, so that if I present a couple of images whose subjective score differ by that delta Q, 75% of people will say, this will recognize the image with that there is one image with better quality. And basically, to do that, okay, we fit another. I mean, it's the inverse, kind of inverting the Truston model with the probit model, saying what should be the delta, so that the probability of getting a correct, so that the probability that the subject correctly classified the two images is going to be exactly 75%. Okay, so we estimated also this delta Q as our just noticeable difference using a threshold here, as you see, of probability of 75%. This is probably the point on which I would like to have a brief discussion with you today, because we were discussing whether we should go with a 66% or a 75%. About talking about the literature of just noticeable difference is not very clear about that. Okay. Now, let me show you, quickly discuss a few results here. The first thing, as you know, is always verifying that the data that you collected are reliable. And in particular, what we did here is that we use this anchor set of 50 pairs, if you remember. And in particular, for each subject, we encoded the choices of each subject on this 50 pair as it follows. So we put 0 if the subject chooses the first image on the pair, 1 if the subject chooses the second image. So for each subject, we have a vector of 50 0, 1 values. We evaluated how the vector of one subject, how good the vector of one subject predicts, okay, on average, the vector of the choices of other subject. Okay, and the blue bars that you see here is the average prediction accuracy with which the one subject predict the order on the anchor set. Now, if we compare these real subjects with a random scoring subject. So we just simulate a vector of the random 0, 1 values and use it to predict the other subject. Okay, the red line that you see is the average prediction accuracy of a random scoring subject or a random scorer, and the shaded area that you see around is the confidence interval. What we can see here is that people are predicting, real subjects are predicting in general the score of the other subject, okay, with more accuracy than what you will obtain just by guessing, okay, just making the choice at random. There are three subjects, okay, for which this conclusion doesn't hold, and we excluded them for the subsequent analysis, considering them as people that didn't perform well during the task. This green line that you see here is a sort of let's say consensus line, because we obtain it. The green line that you see here will be the accuracy of a virtual subject that always pick the choice made by the majority of the subjects. So it's a kind of consensus. We wanted to see with this analysis whether people are closer to a consensus. They are more closer to a consensus than just scoring at random. Okay, so the results suggest that they are basically. It seems that they were rating a common task. Okay, something that could explain why they are going closer to a consensus. So let's say this first analysis suggests that probably the data were okay, at least that we did well in selecting people, training them, like letting them really understand what was the underlying task to compute here. Another another experiment we run to verify the reliability of the collected data is about the reliability of the subject to classify the cluster, to recognize the cluster without being told, okay, what was that there was an underlying clustering, okay, that there was a clustering approach behind the pair they were rating. And in fact, when comparing images beyond to different clusters, the probability of choosing the image with greater, there was always, let's say, a higher probability in choosing the image belonging to the cluster with greater objective quality. Okay, the point here, we are not saying that okay, being aligned with objective metric means you are reliable, but at least objective metric should capture the general trend, and subjective score to a certain extent should reproduce that for us to have a reliable data set. Okay, now let us now start talking about the statistics, the simple statistic that we introduce. And in particular, remember that this statistic that we introduced define the cluster. Look at the distribution of the subjective score, okay, between the different cluster. Remember, cluster 3 was the cluster with high disagreement of metric. I can go back very quickly. Cluster 3 was the green one, okay. What happened in cluster 1, 2, and 4? What happened in cluster 1, 2, and 4? There is a very compact. Okay, cluster 1, 2, and 4 are very compact in terms of let's say distribution of the subjective score. Okay, this corresponds to the fact that the STD rank, the objective measure of agreement was also very, very small. But this we can the width of this cluster here, okay, we can report it in terms of just noticeable difference. And in fact, this second analysis basically report, okay, the percentage of pair of images that differ by a certain number whose quality differ by a certain number of JND in each cluster. Okay, what you can see, for instance, is that almost for let's say 95% of images in cluster 1, 2, and 4, okay, even more than 95%, the people perceive, okay, stimulus as not differing by more than one JND. Okay, JND. Instead, in cluster 3, okay, there is a more, let's say, cluster 3 there is a higher dispersion of score. And in fact, you see what we are seeing here is that the width of that cluster is around, the width of cluster 1, 2, and 4 is around, let's say, 0.16. That was, when we estimated our JMD on the quality scale, it was 0.16. Obviously, here we scale with the quality score from in the interval, we scale the quality score into the, we normalize it, sorry, the quality score into the, on the range 0 to 1, just for an easier interpretation. So please keep in mind that the JMD is that we estimated is around 0.16. Okay, so the conclusion here is that if you pick images on the large scale data set, if you pick images with similar value of min rank, okay, but very small value of STD rank, then you are likely forming a cluster or a set of images with similar perceptual quality. Now, what can we say about this ranking statistic and their accuracy? For each, let's say, for each metric, we regress the predicted score to the subjective metric using the usual logistic fitting, and computed the distribution of prediction errors. And this box plot show you how prediction error are distributed, okay, inside the clusters. I mean, why we could expect that for cluster 3, okay, we expect larger metric disagree, so probably they fail in predicting the subjective score. What is surprising is that in the cluster where metric agree, okay, the prediction error, okay, the distribution of the prediction error, okay, provide values that are, okay, remember, that are in the range of the just noticeable difference. Remember that the estimated just noticeable difference was 0.16. And if you look at the distribution of errors in the case of cluster 1, 2, and 4, you see that we rarely go beyond this 0.16. That is a just noticeable difference. Okay. So again, suggesting again that a strong agreement of metric is an indicator of reliability. Okay, now coming to the sensitivity of the matrix, what we did is that we evaluated the probability that a metric misrank, okay, to a pair of images as a function of the perceptual distance between the two images. So what do we mean by misrank here? Let's say that people say that image A is have a greater subjective score than image B, but the metric predict, okay, something that is not current with this choice. So what we could do here is to take each pair of image I and J and define and say that the metric, okay, is performing, it's making an error when the metric, the metric is making an error when the metric, oh, I mean, sorry, I did a mistake in writing the thing here. But by the way, the metric makes an error when it doesn't classify the two images as human does, okay? And so you can define, you can figure out, okay, for each pair of metric, what the matrix does, okay? And for each pair of metric that you take, you can also estimate the distance in terms of number of JMD and fit a logistic model to understand, to estimate the probability that the metric is going to misclassify for given a certain perceptual distance between the pair. The picture, the figure that you see here is just showing an example, okay, for one specific metric in our data set. We did the analysis both at when we evaluate the metric score at the native resolution of the image, as well as a full HD resolution. That is the resolution at which we did the subjective test. And what we see here is the vertical lines that I put here is to highlight, for instance, what is the number of JMD that are required to make sure that we reach a misranking error, okay, of 5%. And in fact, if I take the dashed vertical line that you see here, you see that we need to go more than 2, almost 3 JMD for this metric, okay, to classify images with a misranking error, that is, with a misranking error of 5%. In fact, I summarize the result here for all the other metrics in terms of what is the number of JMD in terms of perceptual distance required for each metric to guarantee a misranking error of 5%. The best metric in this case was linearity IQA, okay, for which at least we still need up to 2 JMD, okay, to guarantee that the metric is going to correctly rank the 2 image. Now, another way to discuss about the sensitivity of the metric, we could kind of ask ourselves, what is the minimum delta of the metric that is required to induce a 1 JMD? Okay, so by how much should I increase the metric score to make sure that people perceive what 1 JMD of improvement? Okay. Again, here, I'm not going to go into the detail, but you can again estimate all this with a logistic model. And coming again for this specific metric, doing the analysis again at the ultra high resolution as well as the full HD resolution, you see that for this specific metric, okay, we need a delta, for instance, of let's say, if we focus on full HD, on the native resolution, we need a delta of 1.5 to guarantee that people will perceive a JMD of difference with priority 95%. Again, this is both in this case, I was like in this case, okay, we get better results when we make the inference at the full HD resolution, okay. And this again summarize in this table here, okay, I am summarizing the result for all the metrics, and in particular, since you see that this 1.5 is, I mean, it doesn't really make sense if you don't normalize it, okay. In fact, I said, let us in the world data set, the range of variation, the range of score of the metrics, okay, we can take the world range of variation of the score of a metric, okay, as a baseline, and basically do what? Take the delta M required to perceive 1 JMD and divide it by the total range of variation of the metric within the data set, okay, within the data set, to define what you could call a normalized discrimination threshold of the metric, okay, just to see, so by how much in terms of percentage I should vary the operate on. I should make an increase on the operative range of a metric to make sure that I perceive a difference. Okay, so this basically should tell you that for the again, the best metric here was linearity IQA, but in general, for most metrics, you need a variation of at least 20%. I think both this result as well as this one basically suggest that there is still room for improvement of the or large room for improvement of the current state of the art matrix. Okay, finally, I reported something about the accuracy, the overall accuracy of the metric on the data set. Okay, sorry, I just realized now that scale here means, scale here means the result on full HD content, okay, after downscaling the image to full HD, while the first two columns are the result without, at the native resolution. I put this thing here to have a brief discussion on, if you look at this overall performance, you will say, oh, okay, metrics are correlating, let's say, in a range from 0.7, let's say 0.7 to 0.8 something. But this is the general approach that we use, okay, to evaluate, to assess the reliability, the accuracy of the metric. But something I wanted to bring on the table is how these correlations here drops, okay, if we do the analysis within clusters, okay, and this was expected, right? Because simply this cluster, as we saw before, clusters are images within, okay, that have similar perceptual quality. So even a human viewer will not actually see a real order, okay, a true order within this image. So when we look at the overall correlation, we should not conclude by just looking at the overall correlation. My point here was to say it is important that we make sure that data set on which we compute the overall correlation are not full of, stimuli with similar quality. Because for sure, stimuli with similar quality will kind of have a negative impact on the overall performance of the matrix. Just now, this is another. This is the correlation per cluster if we work at the native resolution of the images high resolution. Surprisingly, when we downscale the images to full HD resolution, we see that metric, okay, the correlation between metric and subjective score increase in cluster 3. And cluster 3 obviously is the one where there is a few number of J and D, okay? So there is space to capture a trend, okay? And yeah, so conclusion, what we could say is that simple statistic on the gradient of metric will allow us, okay, to help us to identify a set of perceptually similar images, okay? The agreement is an indicator, the agreement of several objective quality is potentially an indicator of reliability, okay? And yeah, for what concerns the sensitivity of state-of-the-art metric, okay, there is still room for improvement. So thank you for your attention.
Okay. Thank you, Loic. Are there any questions?
Thank you very much for a very interesting presentation. I have two questions. Well, first is just a comment that I really think that
Okay.
Yeah, sure. Loic, please mute yourself when you are listening, otherwise we'll get echo.
Let me.
Yeah, in Teams. Yeah, okay.
Thank you. So, like yesterday's presentations, the last presentation at SAM by Mohsen and John was really very, very strongly related. So I really encourage you to contact and synchronize your work to some extent, because I think this is why we are here. This is the feedback about it. So this is great. And could you please come back to slide 17? It wasn't clear for me why you divide by the range of the metric, because the yes, it for me it would be like the most reasonable division for me would be if you know that the range is from, I don't know, 1 JND to 10 JNDs, yeah? But yeah, could you elaborate a little bit more? Maybe I simply missed something.
I mean, what I can guarantee, Lucian, is that we saw by analyzing the data that we had that at the end the distribution of subjective scores cover the whole a huge quality, a huge let's say a huge range. And also for the metric, actually, I don't have anymore the score of the matrix in the whole data set, but I checked that most of the metric, okay, did provided scores that let's say that are within the range of I mean the theoretical range. There are metrics like linearity IQ that provides score in the range from from let's say 0 to 100. In the data set, in particular, in this specific data set, I think that they provided score from 17 to I think 92, so a large range. This said, I mean, I will indeed go in your direction and ask a more general question. I mean, even assuming that we have a wide range for the metric, is it knowing that metric are not metric do not behave linearly on your scale, this division could still be problematic. So I definitely go in your direction to say probably we, after estimating this delta M, to compare different metrics, because this normalization was just done to compare metrics. Okay, if we want to talk about a single metric, we could totally get rid of this normalization. But if we need to compare metric, we are still looking for a best way to normalize this delta M for each metric.
Okay, I fully understand. Yeah, thank you very much. It's very clear. So it's the approximation that you take into account. Yeah, very good idea, by the way. Yeah, thank you very much.
You're welcome.
Hi, Loic, very good work. Again, it's nothing, I can say it's a little bit neat, right? So only it's logistics, but can you go to page 7? There's a typo that you can easily fix. You have, I think, somewhere, yeah, you say QI minus QI, obviously one is a J, right? So the phi on the Thurston case V model, you use QI minus QI. Make sure you fix it. Go to page 11. Here, my question is, I don't see the upper bars on the first and third bucket. So you better put these there.
The first is on the edge.
Ah, you have better eyes than me.
Yeah, they are on the edge, basically.
Yeah, so maybe enlarge the box so they're a little bit more visible. And then I think I saw on 13, but I didn't want to interrupt you here. Yeah, I think you mentioned for all metrics, prediction errors in clusters 1, 2, and 3, or is it 1, 2, and 4? You're muted. Thanks for muting. There is some feedback coming back. And again, these are minor.
Okay. 1, 2, and 4. 1, 2, and 4, Ioannis.
So I hope these are not in the paper you submitted. Because if
No,
I were
not
the
yet.
reviewer, you would be flagged by now.
Yeah, I mean, the paper is yet to be submitted, actually.
Okay, so already you got
Thank you.
free. You got a free syntactic review here. Okay, but no. Now to the matter, I think it's very important work. Personally, I feel very excited, and I would like us to. You know, I can only say that the problem of metric disagreement, and we heard from Matthias yesterday as well, right? Because again, it can be multiple things, but the simplest application is that you have a new coding tool, say, to improve compression efficiency by 3%. And then you want to quantify what does it do to the quality, right? So you may see that based on SSIM, I'm picking up one number here, one metric here, right? You have X% improvement, and based on VMAP, you have Y% degradation, right? So it is an extremely important topic, number one. And I think that if we are able to at least quantify, as you say, the way I put it, and I'm oversimplifying a very long presentation, but the way I say it, if we can quantify which regions we trust, by how much, all right? Which regions you do not trust, and again, by how much, imposing these bounds, to me, is a critical, to the point that I would say, once we reach, and I see Sam playing a key role, hopefully. Yeah. It's not, I mean, we don't need to partition, right? Yeah, we are all part of the same group. All I'm saying is that I think there are multiple experts on various groups that can build upon the work. And I would really like us to get to a point that this, of course, works also for video, right? And of course, we start with, as always, right, with images and go to video. But let me say again, I'm bringing it up because part of my vision for IGVQM, right, was to provide to the practitioners that are not necessarily experts on either subjective assessment or even objective metric, right? Not everybody knows exactly how Contrake or other metric, and perhaps they shouldn't be if they're focused on another part, but they need to know when to trust it, right? So I think from that point of view, thank you for doing the work. I like it. Fix those small needs before you submit the paper, and let's work to tie, I can say, this whole corpus of work into something actionable. Recommendation, not, I mean, again, white paper, yes. So please shoot on the white paper, right? That will capture all this. That's it.
Okay. Nice.
And there is Matthias next to me, unless you have a point. So.
Thank you, Yanis.
Thank you. just to follow up a bit, so I think what is really important, I mean, in this standardization process, we are very concerned about what metric to use for decision making. And so that's, I mean, for us it's for video, but I mean for JPEG or other guys it's for images. But the thing is, for this decision making, it's maybe not necessarily so much the question of how a metric would perform on a whole data set, but rather that it would be very reliable on the sequence, on each sequence, so that if you go on that sequence and then you have this, if the ranking of the points for the metric is reliable, that would be super helpful information. And I mean, you know that we use a lot the PSNR, because on that per sequence basis, it's not so bad, and people understand what it does. I mean, this is another dimension to it. Yeah. So because it's and this is the point, right? So if we have something that's better than PSNR on this per sequence level, so that it's really reliable, and the PSNR does not catch a bunch of things. So that's why we do a lot of testing for like loop filters, so things that impact visual quality differently from what the MSE distributions might suggest, right? So that would be really, really helpful. Maybe I don't know, just out of my head, how to extend that that study, but looking at that focus would be very interesting as well. Thank you.
Thank you, Matthias. Okay.
Okay. Any other questions? I can see none. No none from remote. So thank you, Loic. I think we can move on with the next presentation. Brian, are you online?
Yep. Hello.
Oh, hello. Okay. So I think you can share your presentation. Maybe Loic, yeah, you stop sharing. Thanks. Maybe you can say a few words about you before starting, since we didn't see you before. Thanks.
Can you see my screen?
Yes. I mean, you just need to go in presentation mode.
Yep. Okay. So hello everyone.
Yes.
My name is Wei Liang Oh, but everyone can call me Brian. I'm currently a master's student in Deggendorf, so at the Deggendorf Institute of Technology, and I am working under Professor Markus Barkowski, and I am currently doing my master thesis on the topic here, which is modeling individual video quality assessment using eye tracking data. And this is currently an ongoing work, and I have ran a subjective experiment, which I will talk more about in my presentation. So let's get into it. So for my presentation, I structured it into 4 parts. First, I have the introduction and the motivation, and then we'll move into the experiment setup, how it was conducted. And then I will have my preliminary results on what my data shows me. And then finally, we have the next steps on how I will move forward with my thesis. So first, introduction and motivation. So the premise is that perceived video quality is subjective. So that means people can have differing opinions on the same video sequence, even if viewed in the same conditions. And so the goal for my thesis, at least hopefully, is to predict the video quality scores of individuals using a neural network that is fed with opinion score and eye tracking data. So in order to do that, subjective data is needed for the modeling purpose. And thus, I have built a new subjectively annotated dataset. But why a new subjectively annotated dataset? For my purpose, I require stimuli selection that is optimized for individual quality modeling. That means I require stimuli that would yield a variety in individual gaze patterns, as well as stimuli with expected similarities in the individual gaze patterns. This will allow individual neural networks to firstly learn to separate individual gaze patterns from shared attention behavior, and as well as improve personalized quality assessment accuracy through richer gaze variability. So Based on my research, I have not found an existing eye tracking dataset that fully fits the scope, and thus I have taken it upon myself to select video sequences from various existing datasets and put them together to conduct this subjective experiment. So moving on to the experiment setup. Firstly, the experiment environment. It was conducted in a controlled setting that was, to the extent possible, adhering to the recommendation from the ITU-T P910. For hardware, I have a 4K BenQ monitor that was used to display the video sequences. And I'm using a Pupil Labs Pupil Core eye tracker, which is worn on the head. It's a head-mounted eye tracker. For software, I used MPV for video playback and AV-Rate NG for rating collection, as well as the post-controlling the flow of the experiment. And to record all the eye tracking data, I'm using the software from Pupil Labs called Pupil Capture. Here is an image of an observer participating in the experiment. So they'll be sitting at a controlled distance to the monitor. And I have the eye tracking software running on a separate laptop in order to avoid any problems that may occur if I ran all software on the same computer. So I wanted to avoid having any frame drops and so on, and any stuttering that may occur in the worst case. So in order to conduct the experiment, I had to do my source sequence selection. And for my source sequences, they are selected based on their content, which includes fast-moving objects as well as slow-moving objects, objects moving in random directions with multiple actions happening in one scene, as well as a variety of camera motion, for example, zoom, rotation, and panning of the camera. I then applied various encoding parameters onto my video sequences, where I use different quantization parameters, as well as offsetting the chroma quantization parameter from the luma quantization parameter to achieve a little bit of color bleeding effect. I also added a white point shift by adjusting the color temperature of the sequences. And here is an example sequence for one sequence that I expect that there will be a wide variety in individual gaze patterns. So the sequence starts fairly zoomed in and with two ladies very in the forefront. And the idea is that maybe initially people will be focused on the two ladies, but as the camera pans to the left and zooms out a bit, people will be looking at other areas, maybe on the old man on the bicycle, or maybe on the signboards further back in the distance. So here I would expect individuals to have different gaze patterns. And moving on, this is another example sequence that I've selected where the video sequence starts with a camera rig on the left edge of the screen. And as the sequence plays, the camera moves out of frame, and on the right, a lady walks into the frame. And nearing the end of the sequence, the camera zooms slightly in. And this is a sequence where I expect maybe the camera and the movement of the camera and the movement of the lady walking in will attract the participants' attention, and people will be more focused on these areas. So here I would expect people to have more similar gaze patterns where they are looking at similar areas as compared to the sequence before. And I have conducted the experiment, so let's talk a bit about my experiment participants. So I managed to invite 26 participants to participate in my experiment. Their age range is roughly from 18 to 30 years old. I have mostly naive observers, so I have asked during the experiment if they have participated in any similar experiments, and all of them said no. Visual aids, a large portion of my participants use visual aids, so mostly had to wear glasses. On occasions, they will use contact lenses due to the eye tracker being a head-mounted eye tracker, so there were difficulties if they had glasses. So Visual 8 with eye tracker is not easy. And I also conducted an informal visual acuity test before the experiment to ensure that the participants have at least close corrected to normal vision or close to normal vision to participate in the experiment. The participants are also informed about their rights and briefed on the flow of the experiment before the experiment is conducted, and they have agreed, consented to taking part in the experiment. And due to my large number of videos as well as the difficulties that came with using the eye tracker, I had to split my experiment into 2 sessions, and each session had 3 blocks. This will be clear in the next part. So this is the test procedure. First, the participants are shown a training block with 5 sequences for them to get a feel of the flow of the experiment on how fast it goes, as well as to give them an idea of what quality of sequences they will see. The training videos are not in my dataset, so the training videos do not appear in the test. Then they will move on to an actual rating block with 46 sequences in total. So each block is about 20 minutes approximately. That is dependent on how fast each participant decides on their rating, as well as if they take any short breaks in the middle to stretch a little bit. So, and between each block, I have planned a 10-minute break session. And that means one session of 3 blocks should last approximately an hour and 30 minutes. However, due to the eye tracking where I have to do a calibration, finding the optimal angle for the eye cameras when wearing glasses, this would take up to maybe 3 to 4 hours in total. So in my experiment as well, I did use a Maltese cross that is displayed before every sequence to do a calibration analysis. So to give a better idea, I have here a flowchart or a timeline. So first, when the subject press start or submit during the rating screen, they will first be shown a screen with the Maltese cross in one position for 1 second, and then another one in a different position for the next second. These Maltese cross are randomly chosen, so for every sequence, they are not the same. This is to avoid any predictions, so to avoid that the participants can predict, oh, the Maltese cross is going to appear on my right, and they'll re-look on the right. Then they are shown a gray screen for 2 seconds, and then the actual video sequence that they are to rate, and then another gray screen for 2 seconds. After that, they will be shown the rating screen where they will choose their rating, and this process repeats for 46 times during each block. So much for my experiment. Now we move on to my preliminary results. This is a histogram of the distribution of all the ratings that I have collected across all my sequences. And here we can see that I have a variety of ratings distributed across the 5 rating categories. And yes, I forgot to mention as well, I'm using the absolute category rating scale. One point to note is that for the category 1, so for the bad video sequences, I have a significantly fewer number of ratings. So it could be that I am lacking the variety that represents bad quality. Or number 2, that maybe I have more optimistic participants who are not awarding ones easily. And here I have conducted a mean opinion score against the standard deviation of opinion score analysis to see the validity of the source hypothesis. So in a controlled environment, a controlled depth environment setting, the results should fulfill the source hypothesis. And from my result here, I can see that yes, my results do have this upside down banana shape that is expected when doing the source hypothesis. And we can as well here see that in the category of the low ratings around the 1s, I do have a a bit of lacking points there. And to verify the eye tracker data, I calculated the gaze points that are around my Maltese cross. So I know the point, my Maltese cross points on my screen. I know the coordinates, and I get gaze points from my eye tracker. So I can now calculate what percentage of my gaze points is within a 5-degree angle of my Maltese cross. And here on my graph, the blue shows the ratio of good gaze points within the time frame, so within all the times where the Maltese cross is displayed. And the orange is when I took the first time from the first point where the gaze point is within this 5-degree accuracy, and I calculated what is the ratio from there. So instead of taking the whole time frame, I calculated from the point when the first gaze point is within this 5-degree accuracy. And we can see that across the board that the eye tracker delivers reliable data, so I have a good amount of gaze points that are within this accuracy as expected. So the participants are paying attention to the task and looking at these gaze points as instructed. And so the experiment conducted so far suggests the validity of the collected data. And now the next step is making the data set suitable for the research questions that I want to address, or we want to address in the next step, which are, firstly, are the gaze points over the whole test section different with statistical difference or statistical significance among subjects? And if two subjects give the same rating, what is the probability that this results from looking at the same locations, or are they looking at different locations but still giving the same rating? And if two subjects look at the same locations, are they going to rate similarly, or is a bias correction enough to account for this? And lastly, do gaze points improve the modeling of individual quality assessment? So then I would then be training an AI observer, firstly, without taking into account gaze points, and then using gaze points as I collected them. And lastly, when I shuffling the gaze points around, so mixing the gaze points around either within a sequence or between sequences. So thank you for your attention.
Okay, thank you. Thank you, Brian. Are there any questions from the audience here? Yeah, please. Lucian.
Thank you very much. Very interesting talk and well done experiment. I've got. I just wondering if you recorded the time of rating, so how long it took to make the answer.
So I did not record specifically the time for the rating, but I do have logs where it tells me at this timestamp my video player has finished, and I have a timestamp for when the person clicks submit. So I can then from there calculate how long it took them to do a rating. Yes. Okay,
because it's interesting when you compare it to the talk from Michał Wierzchoń. This was 2 days ago. You can see the talk. It's from psychology more point of view, and they are really paying a lot of attention to how fast people answer. Mm-hmm. And what is interesting, they actually kind of they are considering removing someone because she thought too long, and you kind of force them to thought at least 2 seconds about the answer. Yeah, so this is interesting. Yeah. The interesting is this idea of the experiment where you actually force someone to think at least 2 seconds about the answer before they even can make an answer. Yeah. So I'm just wondering how it looks like. It's like a curiosity. It's a small comment. Yeah. I've got 2 more small comments. I will be quick. So first of all, the source hypothesis. It's not about like checking if your experiment is correct. the thing you should do is to fit the correct curve, and then you get the coefficient. So if you do what is described in the paper, like fitting the specific, because it's not like a typical curve, it's there is a one parameter. So you fit this one parameter and you get the value that actually describe your experiment, how precise it was. And actually, I guess that your experiment was very precise. Like looking at the points, I guess that you have a very precise experiment. So the A parameter will be, I think, below 0.2 or something like that. But you can check it, and so this is one. And the other is the moment you would like to test if the people looking at the same part of the screen have the same answers or similar answers, I think you will need more than 26 participants. And the reason is very simple. Let's say the half of the participants look at the same well, they have the same pattern of looking at the sequence, which is a lot. Yeah, it's like half of them doing the same thing is probably not so probable. Then you only have 13 answers, and then testing the distribution, the similarity of a distribution for 13 answers will be difficult, simply because you've got very little data. Yeah. So the question is very, very interesting. That I'm afraid that you need more data to be able to really reliably answer this question. But maybe I'm wrong. Maybe lots of people are doing similar things. Then you are fine. Yeah. Okay. Thank you very much.
Thank you.
Okay, thank you. Any other questions? Or anybody from remote? No, it doesn't seem so. So I think we are done with the JGAIB session. Thank you for attending it, and thank you for the valuable feedback we always get at WCAG meetings. So I leave the floor to Jan.
So let's bring up the agenda. Okay, so as you remember, since we have approximately 20 minutes now, is it a good time, Pablo, to go over the liaison statements?
Okay, give me a second to find everything. Okay, so I will share my screen, hopefully. This one. Okay, probably make it bigger. Even. Okay, so well, I mean, I believe the header is not much to be changed. So, well, there's something to be discussed, even if it's small. We normally engage with the study group 12, having a very short conversation with Martin at you. He said that what we do might have some impact to the people not only doing kind of measurements, but actual architectures for management, let's say. And he mentioned study group 12 that has, I mean, study group 13 that has some relationship with that. And well, 21 is actually the coding run, right? Which might be also relevant. So since it's just sharing information with them, I think it's okay just to send a liaison statement to them. Even we are definitely not attending a study group 13. Maybe some, well, of course, some. There's people here attending a study group 21 for different reasons, right? But still, I think it might make sense. But I don't know if there's any opinion for or against it.
I think it's a classic case where the more the merrier, in my opinion, as long as there is relevance and potential interest. Since you are editing, let's fix the Sweden typo. And then you can put my phone number.
Yeah.
+1 650 492 1567.
Okay. So I will. It's difficult to edit with the microphone, but I will do here. So this is the text. So we are for Oxford, comma. Okay. There's a lot of discussion around whether, of debate whether this is the right or not. But I really don't. It's not my language, so I don't mind. So this is, yeah, we don't have more text. So this is it basically. I think.
So let's give everyone. Can everybody read the text? So please spend the time to comment if you say anything that needs to be edited now.
Yeah. So if for the ones who are online as well, please read it. I don't think I need to read it aloud. It's readable right from there. Okay, I will do it while you read. So I think if there's no more comments, if there's any comment from the audience or
someone from the audience, I mean from remote, raise their hand. There was a.
Yeah, I briefly raised my hand. As I said, I'm not in the room. Alex speaking. I just stumbled a bit about the over the VQuake expects that the document may be useful. I mean, I find it a bit awkward as formulation, but I'm also not my English is not my mother tongue, so the expects I find it a bit pushy, but maybe that's indeed our expectation. So I think it's probably fine. So I lowered my hand again.
Do you have a different term that you could propose, perhaps?
Just beliefs or something, right? Or things. But it's a really super minor point. Just, if we are asked to review it and we have it on here for a while.
Expect is okay?
It's fine.
Yeah, I think we're going to stick with expects and let the other party perhaps complain. Okay, so let's go to the second then. We have one more.
Yeah,
Okay.
this is for the telecom infra project.
Yeah.
Is it readable? I mean, the font size?
I think you can go one click higher and it will still fit in a single page, I think. Yeah. How about now? Okay. Let's give people some time. Let's do the same white paper capitalization.
Oh, yeah.
You mean to define TIP? You can just put to telecom infra project parenthesis TIP and then you have the definition on the two. I mean, yeah, exactly. Then we're all set, proper. Thank you. Anything else?
So I will de-highlight the part that, I mean, that was, so this was like the basic only difference between this and the ITU.
There is a specific group, right, within TIP?
Yeah, this is a specific group within TIP, which is, let me, well, I can try to, let me share.
The term QE? Okay, so then, so liaison statement or white paper on quality of experience, parenthesis, QE, aware management should suffice.
No, but this is the title, I guess. That is why it's title.
No, I'm talking about before the title that's italic, there is another informal liaison statement. We can, I think, put it there and be done with the definition.
Here?
Yeah.
So yeah, the QE management group is actually the group which is in charge specifically of this design of common QE metrics and exchange mechanism between CAPSA and CSP. So this actually its mission according to the website.
Fits exactly into their charter, I guess. Okay.
Okay.
Then let's.
Good. So
okay.
I think we can have them approved. I will, if that's okay.
So we are formally approving these two liaison statements as they were shown to the group and also for the people online. Any objection or? Okay. Hearing none, they are formally approved and they will be sent out. Thank you very much, Pablo, for driving this.
Thank you.
Which brings us to 10:19 local time. We can have either 11 extra minutes of coffee and chatting about yesterday and about. All right. So we are adjourning 11 minutes ahead of schedule, but we are still planning to resume on time. Unless, did I get the schedule? Can you please bring up the schedule one more time? I now have second. Yeah, so we are coming back 10. Yes. Oh, yeah. Thank you for bringing that up. Yeah, so quick update. First of all, there is no action, formal action. The topic of the discussion for those online is the legal status and let's say the administration of VQUEG. I'll give you a couple of updates. Update number one, there has been no contact with lawyers to further consult. And I remind you, there were at least 3 different courses here. Course number one, we go our own way. We establish a non-for-profit, incorporated in the US. And then we control our own destiny and we have a legal entity and everything that means, pluses and minuses. Second idea was to be part of an existing nonprofit like the JDF. And then they allow you, but there is a membership fee that one can argue that it is still less than by incurring all the costs for, you know, filing the government and tax-related documents. And option number 3 was to do something similar in another part of the world. Allow me to use the word, for lack of a better term, for better neutrality, if there is such a thing these days. So unfortunately, none of the 3, as far as I know, has been pursued. Everybody, I think, so it's still pending. The second item, although that is not pending, is that we have a domain. We have a yearly subscription to a WordPress, service provider that I maintain personally. And what I would like us to move forward is to create, at a minimum, a mirror image of vquake.org, which, as you know, right now is hosted by Margaret's group. And at a minimum, I would say, as a consistency and as a backup, me and Cosmin undertook like 2-day effort where we pretty much reflected and put together all the information that was available a year ago. So my ask is the following. Again, the financial part I'm taking care of, and there is no need to discuss it. But the actual operation of taking and reflecting, at least at a minimum, what is right now on vquake.org, while we expand on it later, needs volunteers. So we can set up either an email thread and say, hey guys, who would like, because to be honest with you, I had never used WordPress. I raised my hand, I learned it on the job. It took me approximately 30 minutes and then I was, running with it. Perhaps now one of the many coding agents can actually do that even without us. So I would be very happy if someone says, Yanni, don't worry, just give me the credentials. I will invoke and I will make sure everything is reflected. But we need an owner, right? That's what I want to elevate. I can take care of the back end, creating credentials so people can access it. But it would be really good if before or by the time of our next online meeting, we have, again, the idea is very simple, a website that is totally controlled by us without really being, I don't know, Metas, or US government or anybody else. We shouldn't rely on, anyone external. It should become with our own means. And then at some point, once we feel comfortable that this mirror website has all the information we want, the way we want it, right? It is functional. We can either switch over and just transfer the domain. So then the domain will simply reflect on this new IP, or we can decide to maybe modernize or add the currently missing features, and together with Cosmin we discuss about, in my opinion, 2 or 3 features that would be really, really helpful, right? To have the sort of online collaboration through our website, where you create an issue, those who are subscribed can get notifications, etc. So how shall we do this? First of all, any questions or comments about what was just said?
Yes, I was checking yesterday about the DOI thing and the reason why it might not be yet indexed in Google Scholar, and I found out that there are some requirements about metadata in the landing pages that I will try to fix, but also that somehow Google Scholar crawlers assume that the landing page and the PDFs are stored together. Mm-hmm. I don't know if it's mandatory or not. We will figure out, but still, probably having everything together under our own control will also be beneficial for basically for the DOI things, because otherwise I'm not totally sure that we are going to really be able to have the things indexed by Google.
And the impact we're hoping for. Thank you. So this is also important. So again, let me say the long-term vision is rather simple, right? Standalone IP controlled by us and us only, and then act as a file repository, right? The PDFs, the metadata, all the content we have, be interactive, allow me to say more, so attractive and easily accessible to all. So we have a mobile-friendly version, right? That anyways many people would like to use. Enable communication amongst ourselves through the website. Cover emails and email reflectors, etc., etc. So that's really the North Star, which I just could not move forward by myself despite those 2-day effort that me and Cosmin put together. So if you have a volunteer right now, I would love, okay. Very good. It's much more than mine, okay, I can tell you, because I started from zero. So, all right, thank you, Enrico. So offline, I will communicate, send you the credentials, and you can inspect what is the current status. And very happy if we need, because I got the package called Standard. There are other packages that cost a little bit more money that give us more functionalities, which we can discuss if we need as we move forward, right? So, but very good. So that's the update on the website. So I would be very, very happy if by December or wherever we hold the online, we have reached that milestone. And I think it will also make Margaret very happy because, you know, her own, let me say, concern is that she does not control what her office and her department will decide to do. And the fact that then it's up to us to update, say, the website, right, ourselves, or to do any action without sending it to Margaret, and Margaret asking her staff is really shortening the loop and making us, I think, puts it in a better place. Anything else? All right, so 3 minutes extra coffee time then. Okay. Okay, welcome back. We are now going into the last, but not least actually, one of the very important these days projects, the 5G KPI. So I give it to Pablo to walk us through the presentations.
Yeah, thanks. So we have 3 blocks in the session today, as I presented on Monday. So now we will have 2 presentations on topics which are relevant for the 5G KPI project, starting with Camille and then with Eric. Then we'll do the lunch break, and then we'll have 2 slots in the afternoon. First one will be mostly about presenting some, so briefly checking the status of where we are about the white paper and having some presentation about possible follow-up ideas that we could explore, kind of the midterm. And the second slot, so final slot of the day, would be more a working slot to discuss on 2 specific ways forward. One is a very concrete one, which is sending some contribution about the QE definitions to ITU, and one is a bit more open, which is testing or validating or simulating or whatever some of the ideas from the white paper in real life. So stay tuned, long session, but very, very interesting topics.
Yeah, thank you. So, hello, my name is Kamil Koniuch. I'm a freshly defended PhD here at AGH. And today I would like to have you to take you on the trip back in time. So a few disclaimers before I start. First one, I'm not historian. Second one, some resources that were needed for this presentation, they're actually placed in libraries, only physical copies in countries that I couldn't go. So some of the scope is limited and also this research is a bit of early stage. But I love to show you the rabbit hole I've fallen into. So please follow the white rabbit. Okay, so why I put this presentation in the session? So when you are reading literature about how to propose new definition or how to improve definitions in science, you have many steps, you have many things to do, but always you have survey of literature as the first step, yeah? So I thought I will do the literature survey that might be used also in a discussion, discussing the definition, which is part of this session later on. So in terms of Mateusz, you are changing something and I cannot change slides when you do that. Yeah. So fortunately, I don't have to do this for QE because it's already done. It is really good paper by Christian and Tobias, where they actually put on the axis the different usage of QE term in time. Yeah. So I think this is part of the research that should be used during the discussing QE. So yeah, we find the rabbit of quality of experience. Yeah. What is the problem with chasing this rabbit? So this rabbit will take you only to 90s. And actually, in 1990, this paper, it's from philosophy. It's about problems of qualia, which is related, but it's not like telecommunication paper, yeah? So it's the history of the term, but not necessarily its meaning, yeah? So what will happen if we chase the rabbit of quality of service? And Tobias and Christian didn't do that because they stated that, well, it's mostly about system. We care here about the human, so that's the different story. So I chased that rabbit. So if you chase that rabbit, for example, in 25 years ago, yeah, the ITU standard G1000 was published, and it's still in force. And you can find the definitions, for example, of quality. So quality is the totality of characteristic of an entity that bear on its ability to satisfy its stated and implied needs. So it's after ISO. There is also, in the same standard, definition of quality of service. which is the collective effect of service performances which determine the degree of satisfaction of a user of the service. Quite similar to what we do, yeah? There's also requirements of QoS, so a statement of level that the quality is needed, and something that is, well, basically the definition of MOS, I guess, or ACR. So perceived quality of service by user customers is a statement expressing the level of quality that customers believe they have experienced. So 25 years ago. Let's see for another standard. It's, well, quite similar in this version from 2009, but actually the standard E800 has previous version from 88 and 94. And in this version, we have quality of service is the collective effect of service performance, which determine the degree of satisfaction of user of the service. So we have satisfaction, then we have needs. There is some change in that, but going outside of ITU to different bodies. So for example, I found this report for US department where they were interested in voice band quality of service. So in this paper, the quality of service was defined as quality of service is in this report refers to end user's perception of the entire process of call setup. So we have first perception, then satisfaction, then needs. So we already see like evolution of the concept of quality of service looking for these papers, yeah? So, but you can still argue that, well, this is still about system and services, not about human, and what we do here is mostly focus on humans, so something that is exceptional for QA is human factors, yeah? So let's chase the rabbit of human factors and let's see how far we can go. And this is actually the first moment, for me at least, when I was reading the literature, where I have this jaw-dropping moment, because one of the first papers I found with this historical approach looking for human factors was this one. So, yeah, we have International Symposium on Human Factors in Telecommunication in 1972 in Stockholm. Like the opening of this, well, first thing you can read in this paper is telecommunications are often used by the rather small groups. That's typical case of being two-person conversation. Yeah, that's the first part maybe is not that relevant today, but the second part sounds really familiar. Yeah? Even at this micro level, the interaction is affected by a highly complex set of technological and psychological variables. 1972. But you may think, okay, but maybe this is some obscure venue for psychologists, yeah? And so inside you can find categorization of factors, not only human but technical. You can find ACR scale, and they try to map it to the ACR scale, so quite similar to what we do, yeah? You can even find like causal models for human factors, yeah? Which is something I tried to do in my PhD, but I was unaware actually about this venue, unfortunately. So by chasing this rabbit, I discovered this venue of human factors in telecommunication. It was a venue that was met every 2 years. It started in 1961. The first 4 meetings was actually human factors in telephony, so that might be misleading. And the problem is that most of it is only available in libraries. So to be able actually to reach full the definition from this period, yeah, we would like to go. We have to go to the libraries. Actually, fortunately, the number 5 and 6 is in the library of ITU, so it could be obtained there. The rest is rather local libraries. Some of those are like this one from 1972, you can obtain it by paying for Google Books. I didn't do that, but at least part of it is available without the paywall. So, also from perspective VQuack website and DOI, I hope we will not share the faith of this venue. So it would be nice to have things that are also digitalized and easy to grasp later on. Okay, so. With this white rabbit, I already end up in 1961. So I think, okay, so by going more and more abstract, you can go deeper into the rabbit hole. So I started to chase the rabbit, which is called opinion tests or subjective tests, to see what is there. And yeah, once again, I was not first one to do that. Pablo 3 years ago actually did that for a transmission rating scale. He found it useful for himself. He did like review of this concept, and that's the perfect example that it's still relevant to do this type of study. And Pablo is the reason why I fall into that rabbit hole. So yeah, the oldest paper Pablo cited there was 1931, and I see it as a challenge. But lots of, like, all of those papers that Pablo cited in this work was from Bell Labs. So you might think, okay, Bell Labs did like lots of things, so it's easy to, you know, focus only on them, but maybe it was not that relevant by that time, or it was only limited to the Bell Labs. So this is the Red Book of First Plenary Assembly of CCITT, so today is ITUT. This Red Book was published in 1956, and in this Red Book, study group 12 was assigned to do subjective tests with this scale, which is ACR scale, and what they do, of course, they were mapping it to the quality.
When coming showed it to me, I was like, when they after one?
Sorry for the.
I don't have answer
for the remote participants. There was a comment by me that the scale we see is ACR -1 because it's 0 to 4, and then Lucien jumped and said.
Yeah, because it's not -1. Actually, our scale is +1 because this is historically the first scale. So the question, who adds one and when?
Yeah, that's why we need to dig deeper, yeah, to be able to answer for such questions. I'm not sure. And also, like Pablo mentioned before this presentation, that 0 in terms of Bell Labs, it was hanging out from the call. So it was behavioral measure to have 0. Unfortunately, Red Book is quite chaotic. It's like, you know, like our meeting notes, yeah? So it's sometimes, yeah, you can find the part where representation of Polish governments were applying to China to join to CCITT in the same document. So quite a lot to read, yeah. So yeah, it wasn't only Bell Labs, and you might think, okay, Kamil, but we are a video expert group. We are talking about telephony once again. Okay. Let's change to this study. So we have this beautiful data set and some plot. So I love this study because in this particular research, I love the conceptualization. So what author write in this paper is, we have independent variable which is called resolution. I can manipulate it with this and this technique. And I'm interested in independent variable called sharpness. And sharpness is psychological variable, so how people perceived resolution. And sharpness was operationalized by something called liminal or liminal units. Do you know the term? Okay, Yanis for sure, but maybe. Yeah. So I will quote how the original author stated it. The term limen is frequently used in psychometry in linear of older terms such as just noticeable difference and threshold value.
And one other very important observation, notice how 1080 was there in the caption back in the 50s. So people had seen the future. Of course, it refers to 1080 observations, not 1080 lines.
It's not, it's not 50s. It's not 50s. That's my second question to you. Could you guess the year of this paper?
I mean, much before, right?
Yes, it's IRE, not IEEE. Exactly, yeah. So for sure, not after 64. No. Okay, so I make you the answer for that. So yeah, 1940. So they had to simulate the television because those films are actually like 35 millimeters film. Yeah, it's Bell Labs, of course. So and it's probably the first study, like QE as we understand it, I guess, and they use just noticeable difference. So I think it's quite nice knowledge to have. And there's really beautiful follow-up 10 years after that, where there's also stimuli comparison with the scale. It was comments that participant could use. So it's basically the follow-up. It was per comparison 1950 already on the real television with noise added to it. And what authors were doing, they were trying to model it for. So echo is the like distortion in modern terms. They were trying to model it depending on the video they used, but also they seen that noise that they are applying, it works a bit differently on different resolutions, so they weighted it. So you have the signal to noise weighted noise ratio to try to model it. And you have also the comparison between this liminal experiment and also the experiment with the statements, which probably gives us the scale later on.
Yeah, and also the fact that things work nicely in speech experiments and horribly in television experiments.
Yeah. So, but I think it's like first one, like our second one, like really early stages. Yeah. So just for fun, to go deeper than Pablo, this is a paper from 1929. It was about telegraph's quality, and the operators were measured both in terms of utility, so how they could perform under different distortions, but also how they rate the quality subjectively. And to put the bar higher, I found this paper, Telephonic Intelligibility. It's not about the quality directly, but it's a comparison of which letter people tend to mix when they have hearing tests. So the speech itself, and the comparison was between a real life setup where like 96% of letters were recognized comparing to the telephone. So maybe not like ITUT standards of the day in terms of methodology, but for example, in Marta PhD, the approach was similar, yeah? So something I think close enough to mention it here. But yeah, going back to the original paper of Tobias and Christian, they changed a bit the title of Coen Brothers film to, I'm really bad at Old English, so I think it's OQ where Alt Tau. So I would like to go to this question and trace the reference back. So to Shakespeare, yeah? So Romeo, where art thou, Romeo? So QE, why are you QE? And the second part of this poem, of this play, this part of the play, I would like to pay attention to that. It's what is in a name, that's which we call a rose, by any other name would smell as sweet. So if we call the rose any different, which is will it smell differently? So I would like to consider that, and to make it tangible for you, I actually printed those papers from 40 and 50. I have 5 copies of each. I would like you to have some of them and judge yourself. Is this QE research? Is this quality of service research? Or this is something different? I think they can be like really interesting for you. So conclusions. The concept and definition of quality of experience, quality of service are inconsistent and are overlapping, like through the history. This makes challenging to trace a consistent research lineage. So I didn't know like most of this research, like when I started working in QE. Thus, one might think the subjective studies in telecommunication have shorter history than they actually do. And 4, and I think it's the most applicable to the discussion later. So historically, both QE and QoS were operationalized in relation to concepts such as perception, satisfaction, acceptance, needs, utility, with the dominant role of perception. So you have just noticeable difference, or Lyman paradigm, yeah? You have scales that were mostly perceptual. So the dependent variable changed in different definitions, but people were using like similar methods for over 100 years, yeah? And I think it's, well, in line with the state of the art, where like most of methods and almost all standards of ITU are focused only on perception, yeah? So it's good to have this perception that in practice, what people usually do is perception. Also, we can change the dependent variable, but it's, yeah, for sure it's never delight, yeah, itself. So yeah, thank you, and I would like to leave you with, I think, what is the oldest representation of Alice in Wonderland and in motion picture. Yeah, and you can see the white rabbit here also. I have different video on this screen and this one. But yeah, it's the same, but oh yeah, this is what I would like to show you. So yeah, thank you, and if you have any questions, please ask.
So are there any questions or comments from the audience here? Alex? Alex, please.
For some reason, I cannot really unmute my video. Do you see me now somehow? I don't see me.
Yes, yes.
Gallery.
Yes, we can see you and hear you.
Whatever.
Alex.
Yeah, it doesn't matter. Okay, so yeah, thank you very much. Very interesting historic review. Since I'm also working on speech quality, as you know, there is actually quite a bit of attempts to merge these views in a better way from that community, I would say, right? So, for example, in the E model, right, the scale that is used therein is actually the transmission rating scale that was initially developed by Bell Labs and AT&T, right? And even in the standards P120 something, right? Some of those actually are built on the same philosophy of the transmission rating, right? So I would be very delighted, Camille, if we could maybe discuss this offline a bit more. But I think there is actually maybe not to the knowledge of the VQuake group so much, but there has been quite some work also to harmonize these different concepts, right? And the second point, there is this QualiNet, obviously, definition that has been fed into the definitions in ITU in a probably suboptimal way. And with Pablo also, we are actually discussing, and I think it would be good to really get to some sort of workshop offline before the next ITU meeting or so. How can we modify those definitions in a better way, right? I mean, especially the QE definition, so that it actually is a bit more tractable. And I think the white paper, 5G KPI white paper, has quite a few interesting additional definitions, which may help to summarize, to underline the concept without necessarily ditching the now, I think more or less stable definition that is in ITU for QE at least. With regard to your QS considerations, right? I agree with you, but also there are some of other further complementary overviews and reviews that I would like to bring to your attention, Camille. Maybe it's a bit unfortunate that I'm not yet there, but I will be there for lunch, and maybe we can discuss it then. Would be very delighted. Thank you very much.
Yeah, I 100% agree. The transmission paper and its like the transmission work of Bell Labs and its influence on the E-model was done by Pablo. That's why I cited this. So yeah, I'm well aware of that fact. That's the first thing. Second thing, yeah, I was in the last ITU meeting also, and this is the reason why I brought it here. Yeah, like this historical perspective, because I think it should be part of the discussion of the definition itself. And I think it's like quite important to have common ground in terms of theory, maybe like not the definition, but description of the discipline or a field that actually can bring those two together. It's quite important because if you would like to have some researchers from other fields, or if you like to have new PhD students, well, you need a theory that is easy to learn in a way, yeah? So they do not have to interpret it. So you need strong theory, which is easy to understandable for good communication, and also to keep the lineage, as I mentioned, of the research, yeah? So not to jump from technology to technology, but also have as a discipline some common conclusions, yeah?
Okay, I'm a bit divided about whether simplicity is always the thing that we should teach people, because the world is complex.
It might be complex,
I mean,
but
you will not be learning about AI, for example, if you tell them that's actually easy and you just type in a prompt, right? I'm not saying you said that, but I find that a bit dangerous.
Easy in interpretation. This is what I meant, yeah. So
okay, but anyways, let's discuss offline. I really appreciate your contribution. I think it's very interesting to dive back into that history. Thank you.
Yeah, thank you. Very interesting for sure, and also kind of funny to see how it goes. I have a small comment, maybe coming from a strange direction. So once I was on a conference where there were a company showing some things to detect chemicals. And they said that one of the reasons why they created it was because the highest number they found was a chemical in our body that was discovered 25 times and get 25 different names.
Yeah.
So this really happens, yeah. Like it's not just our field, yeah.
Yeah,
like,
yeah, for sure. I'm not like
the,
here to put blame on anyone. Yeah,
Yeah,
but
that's-
it's part of the process.
yeah, it's part of the process. In chemistry, of course, it's a little bit easier because the moment they standardize how to name the chemicals, it's more difficult to give a different name to the same chemical, yeah. So maybe we could think about something like that, yeah, like not only defining the term QE, but also trying to define more like the systematic way of describing things, yeah.
Yeah.
Like if they have something, then we do whatever, yeah. And if they touch, I don't know, users, then let's say in the definition or some broad name, maybe we could have a name and then a broad name that would be very obscure to use, but would be like unique. So whatever you use subject with this obscure name, you have to get the term subject. Yeah, the moment that there are some subjective answer, but the moment there is no subjective answer, so the people are not asked and only computers are doing some stuff, then you cannot have this in this obscure name. Yeah, something like that. So we could try to think and we inspired by chemists. Yeah, of course, for them it's much easier. Yeah, the chemical substance is a thing, so they study the same stuff for sure. Yeah, it's not so obvious in our case.
Yeah, but it's not impossible for us. Yeah, like so people sometimes send us UX papers, actually, not QA papers. Yeah, so you should be able to ask them some really simple questions like, what is your independent variable? Can you make it HRC out of that? Yeah. Or do you just compare things? Yeah. Would you like to build a model, or you want to just know the answer, which one is better? Yeah. So it's like serious question, and this was I meant about simplicity, but simplicity in understanding the concept, like not have place for interpretation. Yeah. And I think with what I personally think we miss is some kind of tutorial that bring this theoretical insights together. Yeah.
Yeah. Well, thanks for the presentation. You can imagine I liked it a lot. So yeah, a couple of comments. Well, one which was obvious for me that I did similar rabbit hole thing and you, but maybe not for the audience, is that some of these old papers were not easily available until about 5 to 10 years ago. So all the Bell Labs system journal was made kind of openly available, so like public domain about 10 years ago. So some of these old papers were not available to this community just 10 years ago. So this is one of the reasons why they have very few citations. They were not there until very recently, and then when they were there was probably no reason for going so back in the past, because except a couple of crazy guys, nobody was really looking for this kind of things. But still, they're very good because they put a lot of effort, a lot of resources. They're like 2-year-long field studies in those papers, so done by very, very clever people, published together in the same journal, where the next article was by Claude Shannon, right? So it's really worth reading some of them, because they're some of the best QA papers out there. So it's good not only to get the terminology, but also to get some inspiration on how things were done in the past. And yeah, the other thing about terminology and stuff, I think it's a good effort. I think it's good to try to reach ITU at least with the core idea. So let's discuss a bit on the definitions this afternoon, especially because we are a small part of the world. And the term QoE is mostly used by communication people who are much more in number and in influence than us. And they basically only require a cost function for their optimization processes, right? So we really need to respond to that in a way which is reasonable, but also clever. Otherwise, we'll keep being alive in our small community, and QoE will massively be used by other people doing totally different things without any connection to us. So this is was one of the drivers of the white paper. And actually, and to get on Lucian's comment, one of the things that we did with the definitions of the white paper, I think that for me is the most interesting one, is not only defining concepts, but grouping concepts, similar concepts into layers. So we have like categories to say, okay, when this guy in this paper talks about, perceived quality of the multimedia signal, talking about some random guy, it's similar to what we call a perceived QoE in this paper. So it's in the same level of abstraction. It's not system QoE, but it's not quality of service either. So in this way, we can kind of cluster the literature and somehow getting closer to understanding, even if having a totally overarching, obscure term, which is chemistry-like thing, might be difficult to get, but still we might be able to have this category thing.
Yeah, I see. Like the white paper is a perfect first step into that direction. Yeah. And also about the Bell Labs journal that was closed 10 years ago, I think it's quite important to go to this human factors in telecommunications. Like to be able to at least reach the libraries, yeah, if they can scan it, might be good step.
But maybe they're not digitalized. Or
yeah, they are not digitalized.
It says that they shouldn't charge you for.
I don't know.
For some reason, Google Books really do that, but
Because they keep it, yeah. So they charge you for the part they have.
Yeah.
Proxy. Yeah, like a proxy. 75. Oh, so low.
But we can ask AGH to buy access to the subscription.
Okay. So there was a bit of a microphone off mic discussion about whether we should be able to access those papers or buy them or whatever, or whether they should be public domain or not. Okay, I think we can switch to the next presentation.
Thank you.
So thanks, Camille, and thanks, everyone.
if you like to see those papers, they will be here, so you can grab them later.
So next is Eric's, and yeah.
You may be better off to sit by the side so the camera can capture you better. You move on the other side of the table.
You are visible in the camera.
Okay,
Good here?
Yeah.
It's muted, so now it will be working.
Okay, that's better. Yes? Okay. So I'm repurposing this slide deck from last year's COMEX, and so I can talk about the automated mobile video objective testing system that we've developed at AT&T. Next slide, please. So this is a particular use case for that system that's the subject of this paper from last year in collaboration with Ericsson. And the work was done at one of the 3 locations where AMVOTS is deployed. There's Bedminster, New Jersey, 33 Thomas Street in New York, which is going to be the meeting location for this group next year, and Plano, Texas. Plano, Texas has the AT&T Innovation Studio, where we bring together technologies and do experiments with them. Next slide, please. So as a communication service provider, we can't see anything but the traffic and what's coming out of the screen. So the challenge here is to figure out what the key quality indicators are just from what's on the screen. And the best way to do that is by obtaining a reference of some kind, not just for the purposes of computing VMAF, but also for computing startup delay and frame age and so forth. So the secret sauce here in this hardware-software system called AMVOTS is the alignment process. So we have to align every distorted frame with a reference frame. And that alignment process actually also gives us frame age. And of course, we dedupe the distorted frames. They're captured at typically 60 frames a second using HDMI adapter on phones primarily. And that goes into, it gets converted to another form of raw video, which can be transmitted over coaxial cable so the humans don't have to be in the machine room. And that standard is called 12G SDI. So it's professional video level hardware to get the job done. Next slide, please. So we're all familiar with the curve on the right, and the discussion yesterday about the quality of the reference affects the upper right part of the curve, not so much the other part of the curve. So our focus really is on the desired level, being at the knee of the curve. If you're too far on the right, you're wasting bandwidth. If you're off the cliff, then people are unhappy. So the reference should be good enough not to impact the level that we desire to reach. So VMAF is very popular. There are, of course, issues with it. It only considers luminance right now, and it doesn't have an HDR mode and so forth. But we figured out how to run it in real time. And so the MBOT system has both a kind of offline recording to JPEG mode, as lossless as possible. JPEG is a very encode efficient technology. So we're doing the recording in real time. It's important to get every frame during the recording process. And the final QoE models vary by screen size, content provider, phone model, and so forth, and whether it's video conferencing or remote rendered gaming. In the subject of the talk from last year, remote rendered gaming was the use case. So next slide, please. So if you could play the video, you can find the play button. There it is. All right, so this is our alignment QA tool. And so we see we've divided the frame, and you can kind of see the difference in color space and quality, distorted reference, and so on and so forth. And the alignment is based on binary thumbnail images. So we have 1 bit per pixel in each of the color channels, 160 by 90 resolution thumbnail images. Very, very quick to compute the distance between them. The distance is shown in that total there. So the bottom line is we can compute VMAF in real time. There's the VMAF score showing up at the bottom of the list to the right of the blue, green, red images. And we also have frame age, or current time displacement, which kind of bounces between -3 and -5 frames at 60 frames a second. So this is a remote rendered game. We're controlling both ends. And the idea here is if we can measure QoE reasonably accurately, can we use that to control the network? So this is kind of a step in this use case toward QoE-based network management. Next slide, please. Okay. So the Ericsson part of it was kind of to build a dashboard that shows all the KQIs and all the network KPIs in real time. In the real-time mode, we don't write JPEGs to the disk. We do everything in memory. So there's no JPEG. The JPEG loss is minor anyway. We've tested that. But doing HDR, for example, or 4K is more feasible without writing to JPEGs. So do everything in memory, and that means you have to do it in real time because you can't store very much video in memory, although our servers have hundreds of gig of RAM. So Ericsson developed this XMS or QMS system that receives a KQI data stream from MVOTs, and from there we can do network management and so forth. So there's a lot in this dashboard, and this is kind of a work in progress, but it shows the potential if you can get this information in real time for prototyping, how you might manage the network based on these KQIs, and ultimately converting the KQIs to QoE. Now, it's an important point that by computing the KQIs from the screen recordings and then using those KQIs to predict QoE, you are minimizing the amount of subjective testing you need to do. Because that part of the prediction process does require subjective testing, but it doesn't change as a function of the content provider's technology for delivering the content. And so the prediction from KQI to MOS does rely on subjective testing, but you don't have to redo that very often because people don't change their opinion about, spatial resolution, encoding artifacts, and frame rate and so forth very often compared to improvements in codecs. So predicting the KQIs from network traffic can then be done in the lab environment without needing subjective testing. And since we've automated also not only the KQI calculation, but also the packet capture and the UX, the UI for the applications, everything can be run automatically. So we can generate thousands of tests just running the machine ad infinitum. Next slide, please. So just kind of repeat the setup. The reference video in this particular use case, which is remote rendered gaming or cloud gaming as it's commonly called, we're taking the rendered images right out of the game server and feeding them into the capture card, which is part of the AMBOT system. And that serves as the reference video. And then there's a network emulator, and the distorted comes out of a phone where the remote rendered gaming activity happens. So AMBOTS generates the KQIs, VMAF, and frame age, and then the QMS system generates the dashboard with the measurements. We put this together for a joint AT&T Ericsson Tech Summit a couple of years ago. So the AMBOTS runs on a high-end Dell server, 80-core server. The capture cards can handle up to 4K at 60 frames a second, HDR. But we're very focused on testing on mobile phones because obviously people are mostly on their mobile phones on a mobile network, and mobile networks are the biggest challenge for delivering video, and more than half of the traffic on our mobile network is video. So develop this system so that the communication service providers like AT&T can see and measure the quality from the content provider independent of them. But it's very important to have standard view of the KQIs and the QoE so we can collaborate with optimizing the user experience given the limited network resources that we have. Next slide. Okay, so this kind of summarizes the situation here. AT&T is, kind of blazing the trail here as a telecom company in terms of doing this measurement of QoE for video applications. And so we have this lab environment set up using VMAF. We could use other spatial quality metrics like P1204.4. We're evaluating the ITU standards, and I think it's very promising to use P1203.3 plus VMAF. That's our preference, to substitute VMAF for P1204.4 because of licensing issues and so forth. So next slide, please. That's it. Any questions? I know I kind of went through the system pretty quickly, but I hope you understand what we have, and I think it is kind of unique in the world to be able to do these measurements just on the screen recordings. For streaming and normal VOD streaming, we have a kind of elaborate set of logic for determining startup delay and the stalls and so forth. What's actual content, what's advertising, what's interstitial animation. There's all kinds of stuff that happens with video players. And short form video is a whole nother topic that we're tackling as well. Could you actually go back to that video? I wanted to point out one thing I forgot. There, just play that. You notice that on the bottom, we're actually mirroring. do the mirroring when there's a text overlay in the distorted, doesn't occur in the reference. So part of the system set of features here is not only to crop the active video area, sometimes there's a black border or some other thing going on in the player, but to also be able to mirror over with using interior pixels mirrored to the outside to maintain the resolution so we don't have to lose resolution because of cropping out a text overlay. And we've tested this technique and it doesn't significantly affect the VMAP score because the pixel quality is being taken from the interior. Okay. Done. Any?
Thank you very much, Eric. Is there any comment or question in the audience?
Thanks, Eric. Very, very useful. And I'll start by the comment that you made, which I think is very important. Of course, you all understand that the spirit of the 5G KPI, and especially the white paper, is to enhance collaboration. But having said that, I think that the trust but verify
it's a good way to put
approach is the best way to gain confidence to
Yes.
what the other party is reporting, as I say. Allow me to call it like that, right? So to have this independent, again, I don't believe that this is an estimation method, right? And just like any estimation method, it's known to have some errors. So you never expect to get identical results to what the other side transmitted, but it's really, really very useful. And for that reason, I really applaud the approach. Of course, you're familiar that there are other, let me use the word, independent third-party solutions that are selling or at least trying to achieve what you're doing. I don't want to comment whether they're better or worse, but for sure, that's a market.
Right.
So I think that is really building upon a market demand, and I think it's good. It's good more than anything else to me. And again, VMAF is currently being used, and I'm sure there will be better metrics coming up. It would be good to integrate. Probably you need some powerful GPUs, the deep neural network models that come up, like UVQ and others that are being explored. So I would say that while we are doing, let me use the word subjective experiments, which is our golden standard, to be able to swap one metric for another and see how that correlates with what is the ultimate goal, right? So essentially, the proof is in the pudding at the end of the day, right? So if a metric substitution in a big system, in a complete system, de facto is better correlated to the system metrics, that's really what you care for.
Yep.
So I look forward to see follow-ups of this work as metrics evolve on a essentially right off, out of the box kind of plug into the existing framework, how they compare.
Right, right.
These are my comments.
Yeah, the general comment about other vendors, systems, what they tend to be missing is the spatial quality. Specifically, because it's hard to get. You have to do the alignment, and then there's all this, correlation with the subjective test. We do internally in AT&T. We have our user experience lab in Austin. We do a few subjective tests a year, typically about 100 subjects. It costs money to do that, and so I'm excited to validate the ITU standards because they really kind of solve a big problem for us. They get us out of that second predictor having to do from KQI to MOS. It's out of the box. We've actually implemented it, and we're just trying to validate that it's aligned with our own subjective testing results, which are somewhat limited. I mean, you can only do so much subjective testing for long-form video because of all the possible combinations of startup delay installs and video quality changes and so forth.
More questions or comments?
Thank you very much. It's definitely very interesting. I just wondering this system, because I'm not 100%. I think I understand how it works in lab, where the source sequence is close to the distorted ones. But do you also have like something like that you bring it to the real network, like I don't know, in a box or something, and then you record the videos, and then you can check like this is real-time measuring system or just for the lab?
Well, there are two aspects to real-time. There's the real-time recording process, which we can always do. We have 4-channel capture cards, so we can record up to 4 channels in parallel to JPEG. And then there's the processing of the image data. And if it's the real-time mode of the system, then it doesn't write to JPEGs. It processes directly out of memory. And the real-time mode is really useful if you want to prototype we want to prototype KQIs being available somewhere for network management in real time.
But then how you get the source signal?
Well, that's a good question. Typically, the source, and this relates back to the quality of the reference, with a content provider, a streaming content provider, we don't have access to the original content. So we use treat the reference as the highest quality content we can get. Typically Wi-Fi, unlimited bandwidth, maybe on something that's not a phone, Apple TV or whatever.
Okay.
Or we turn off all the data saver modes, and the phone.
Then the system needs like 2 different network connections.
Right. Because again, we're interested in the knee of the curve.
Yeah.
Our use case doesn't really care about the top end.
Okay, perfect. I now I fully understand. Thank you.
Yeah, and if it's, by the way, we do have a GPU acceleration of the alignment. The alignment is very, very efficiently done with these binary thumbnail images, but you can load an entire, movie into the global memory in a GPU and do all the find the matching reference frame for a distorted frame in a very, very short amount of time. So that's also a real-time operation.
Again, just a comment. And that's public. It was in a number of tech blogs, specifically from Netflix, that when a ABR ladder is constructed, typically the highest rung of the ladder is sitting around a VMAF of 95, 96, right? Yeah. So that's pretty much your answer. If you have access to that top quality, and you can get that top quality, say when you're on a fiber, connection, or a very, very high bandwidth Wi-Fi, that's essentially, and you compare that with, say, a VMAF of whatever, 70, right? That's fundamentally very, very close to the cascade of the two systems. Yeah. So that is typically available.
Right.
Yeah, I have a curiosity because I'm not sure I understood how all the metrics kind of connect together, in the sense that you mentioned that you collect KPIs, or KQIs or whatever from the video, so statistics of any kind, but you can also measure BMAF, which gives you a MOS, and you also sometimes do subjective tests. So which is the actual connection? Because I mean, if you have VMAF, you have everything, right? So I guess that you need somehow to correlate KQIs with VMAF, or you do.
Well, VMAF is one of the KQIs.
Okay.
I somehow wasn't in this list of KQIs, but VMAF is the most important KQI, and it itself is calibrated with subjective testing. So the further subjective testing is needed to combine the temporal KQIs with the spatial KQI.
Okay.
Frame rate, because VMAF has no concept of frame rate of time at all. And so startup delay, for VOD, it's startup delay and stalls. And, for the P1203.3, 1 second aggregates are called for, whether it's the spatial KQI aggregates or the temporal KQI. And we have all of that. Ambots puts out frame level data, so you can aggregate it at whatever level you want. And then how you deal with the network KPIs is kind of a separable problem in terms of prediction. So the task at hand is to predict KQIs from the network traffic, because the KQI to MOS prediction is already kind of handled by either our own subjective tests or the ITU standards.
And you're using the 1203 for the aggregation of the different KQIs, or you are like building your model or comparing?
We output the aggregation to be able to input to the standard.
Good.
Yeah.
Thank you.
So
Very nice.
We're looking forward to using the standard. I'm pushing for it. So.
Oh, Alex, yes.
No worries. Super interesting. Thank you so much, Eric. I'm super happy to see, which was also a joint work with VQuake, right? I mean, that the P1203 stuff is also mentioned here, right? I really think it's very helpful to see such results. It would be super interesting to maybe even more officially hear some comparisons also with P1204.4 and maybe also mention the limitations you see there with any kind of licensing model or so, right? Because to me, I think it would be very instructive if the models that have been standardized by VQuake or in collaboration with VQuake, which is the case for P1204.4, of course, Peanuts Phase 2. I would really be happy to learn for future projects, but also maybe speak with the initial developers, right? I know that they are also thinking about some royalty-free solutions also, right? So I really think it would be very interesting to have this be brought up also at ITU level. I would be very happy about that, so that there's maybe some developments so that good models are really even better usable, let me say. Yeah. So, but of course, that's out of my reach. I just want to mention because they are very good colleagues of ours contributing to the standardization activity of P1204. And some research that I'm aware of and internal tests that we did point to the fact that P1204.4 is also quite competitive, right? Besides, of course, the use of the framework P1203.3, which I'm very happy to see you are successfully using it here. Thank you.
Yeah. Now we collaborate with Ericsson heavily on this, and particularly David Lindero, who's maybe on the call now. I don't know. So he's been kind of guiding me on the use of P1204.4 versus VMAF, and it's really it's a licensing issue. But that's why I'm here at this meeting, basically to learn about the details and what to expect from the standards and help drive them too.
Thank you very much. So I think that's all what we have for this slot. So I give back to Yanni to decide what to do with the time.
Thank you to the presenters. Thank you, Pablo. I mean, it's up for the debate and voting. You can either keep going, assuming that the presenters. Okay. Therefore, longer lunch break. Is there any other agenda? We already covered the liaisons. We already have a plan for the next meetings. We already have 3 volunteers. I'm extremely happy to say that now 3 volunteers have access to the tools to create a mirror or a better eventually version of the VQuake website. We're in good shape. So longer lunch break for everyone. Use the time to look around and maybe walk through the city a little bit. I don't know. A little bit risky.
A little bit
come
risky.
back.
Also, maybe Camille wanted to maybe discuss the evening.
Camille?
Yeah, but you can ask, people.
Yeah. All right. So first of all, let's release our remote participants. So we're going to be resuming according to schedule at 2 p.m. local time, whatever that translates to your. So now to Camille to walk us through potential plans.
We cannot hear Camille right now online.
So yeah, we are discussing lunch break.
Okay, so, no worries. Okay.
Yeah, we'll be back at 2 p.m.
Join.